So today we're going to continue on with Chapter 6, Lesson 6.3 in our textbook. And today is really the converse of what we learned last lesson. Last lesson we learned that if a quadrilateral is a parallelogram, then certain facts are true about it. And today we're learning the converse of that if certain facts about a quadrilateral are true, then that quadrilateral must be a parallelogram. So in other words, how you can prove the quadrilateral is a parallelogram. And so the objective is that by the end of the class today, you'll be able to use the converse of the facts about parallelograms that you learned last class to find the value of a variable that makes a quadrilateral a parallelogram. All right, to review, quadrilaterals are any shape that has four sides. We divide them up into three different categories. The first is if the quadrilateral has two pairs of parallel sides, then it's known as a parallelogram. If that parallelogram has four equal angles, four 90-degree angles, then that's called a rectangle. If the parallelogram has four equal sides, that's called a rhombus. And if a parallelogram is both a rectangle and a rhombus, meaning it has four right angles and four equal sides, then it's called a square. If the quadrilateral has one set of parallel sides, then it's called a trapezoid. And if that trapezoid, if its non-parallel sides are congruent, then that's called an isosceles trapezoid. And finally, the final kind of special quadrilateral we have is if the quadrilateral has no pairs of parallel sides, but it has two sets of consecutive sides are congruent, then it's called a kite. And today we're going to be focusing on a parallelogram. So last class we learned the properties of parallelograms. Today we'll use the converse of those properties to prove that a quadrilateral is a parallelogram. All right, in our notes, let's again write down what a quadrilateral is. A quadrilateral is a four-sided polygon, and a parallelogram is a quadrilateral with both pairs of opposite sides parallel, the symbol for which is right there. You can pause this and take this in your notes. All right, continuing on with our notes, there are six different properties of parallelograms, or six different properties of quadrilaterals that if they are true, then we can prove that they're parallelograms. Five of them are converses of things we learned yesterday, and one is new. The first one is one that we learned yesterday, the converse of which is that if both pairs of an opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. And here's an example of that we have these two opposite sides, BC and AD, as well as AB and CD, that those are parallel, so this must be a parallelogram. The second property is that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So again, we see that in this case, the opposite sides AB and CD, the two that are marked in red, are congruent, and BC and DA, the two that are marked in blue, are congruent. And so ABCD must be a parallelogram. This third one is the only one that is not a converse of something we learned yesterday. And that is instead of one of the top two where it says that both sides must be either parallel or both pairs must be parallel or both opposite pairs must be congruent. In the third example, you just have one set of parallel sides, but it has to be both parallel and congruent. So in this particular case, we know that side AD and side BC are both parallel and they're congruent. And if that's the case, then ABCD must be a quadrilateral, that quadrilateral must be a parallelogram. Okay, pause this and get this down in your notes, and then when you're done, move on to the next page of notes. The rest of these are all converses of things that we learned last lesson. So if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So in this example, the angles that are in red, A and C, are congruent, and the angles that are in blue, B and D, are congruent. And if that's the case, because those are opposite sets of opposite angles, then ABCD must be a parallelogram. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So in this case, if we had any of the following, that B and C are supplementary and C and D are supplementary, or any of the other possibilities of any two pairs of angles are supplementary to each other, then we know that the quadrilateral is a parallelogram. Then finally, about the diagonals of a quadrilateral, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So in this particular case, with E as the point where the two diagonals AC and BD intersect, if it is the case that AE is congruent to EC and BE is congruent to DE, then we know that this must be a parallelogram because the diagonals intersect and they bisect each other. So pause this, get this down in your notes, and then when you do, move on to the next slide and do the next problem. All right, so today's objective was to use the converse of the facts, the 6 facts we just learned, to be able to find the variable that makes a quadrilateral parallelogram. So pause here and try problem number 1, and then come back and watch to see how to do it. All right, so to find the value of y, what must the value of y be for PQRS to be a parallelogram? Well, to do that, first I have to find the value of x. And to do that, I can see that opposite sides, for it to be a parallelogram, the opposite sides must be congruent. So PQ must be congruent to SR. In this case, 3x minus 5 must be 2x plus 1. If I subtract 2x from both sides, add 5 to both sides, I get x equals 6. I can check to see if that's right by plugging that back into the equation I just had. 3x minus 5 equals 2x plus 6, so that would be 3 6's minus 5 equals 2 6's plus 1. So that would be 18 minus 5 equals 12 plus 1. 13 equals 13. Yes, that is true, so I know that x must be equal to 6. Now that I know x, I can use it to find y because, again, opposite sides, for something to be a parallelogram, the opposite sides must be congruent. So in that case, PS must be congruent to QR. So x plus 2 must equal y, and we know that x equals 6. So I can plug in my value of x is 6, and 6 plus 2 is 8, so y must be equal to 8. All right, try problem number 2, and then when you're done, unpause it and see if you got the right answer. It's asking us for what value of x must this quadrilateral be for it to be a parallelogram. Well, for it to be a parallelogram, consecutive angles must be supplemental. So in this case, angle P plus angle Q must equal 180 degrees. That's the definition of supplemental. So 17x plus 7 plus 6x plus 12, those two angles together must equal 180 degrees. I combine my like terms, subtract 19 from both sides, divide both sides by 23, I get that x equals 7. And I can check my answer by taking 7 and plugging it back into my original equation. 17x plus 7 plus 6x plus 12 equals 180. So that would be 23x plus 19 equals 180. If x is 7, then 23 7s plus 19 equals 180. That's 161 plus 19 equals 180. 180 equals 180. Yes, I know I got it right. So the value must be x equals 7. All right, pause here and see if you can do problems 3 and 4, and then unpause to see if you got them right. Problem 3 is asking for what value of x is the figure below a parallelogram. Well, for it to be a parallelogram, the bisectors must intersect. Excuse me, the diagonals must bisect. Excuse me, the diagonals must bisect. So that means that FW must equal or be congruent to WH, because W must be the midpoint because EG bisects FH. So if that's the case, then 18 equals 2x minus 6. If I add 6 to both sides and divide by 2, I get x equals 12. And I can quickly check my answer by putting it back into my original equation. 18 equals 2x minus 6, 18 equals 2 12s minus 6, 18 equals 24 minus 6, so 18 equals 18. Yep, I know I got it right. So the answer must be x equals 12. All right, for problem number 4, it's asking for what value of x in the figure below must this be a parallelogram. This one is similar to problem 3, except that instead of giving us both equal halves of the diagonal, it gives us the entire diagonal RT, and then half of that diagonal ZT, because again, RT must be bisected by SQ, because to be a diagonal, to be a parallelogram, the diagonals must bisect. So again, therefore, ZT must equal ZR, and ZR, and I don't want ZR, I want RT, so ZT must equal 1/2 of RT. That's what I was saying. RT gets bisected, so ZT must be 1/2 as big as RT. So now I can plug in my values. 2x plus 5 equals 1/2 of 34. So that's 2x plus 5 equals 17. If I subtract 5 from both sides, divide by 2 on both sides, I get x equals 6. Once again, let's check our answer by going back to our original equation. That's 2 6s plus 5 equals 17. 12 plus 5 equals 17. 17 equals 17. Yep, I know I got the answer. That x equals 6. Finally, let's move on to problem number 5. Okay. So the thing you're looking at right here is called a tackle box. It's often used for fishing, but it's used for other things as well. I've seen people use it for an art box filled with paint or crayons or whatever drawing materials people have. My daughter used to use one for a makeup box. It's a great box. It has a lot of different containers in it, a lot of different spaces for things, and when you close it up, it all closes together. But when you open it up, you can see all the different shelves, as you can see here. And it works using parallelograms. So it tells us here that quadrilaterals are formed on the side of this fishing tackle box by the adjustable shelves and connecting pieces. Explain why the shelves are always parallel to each other no matter what position it's in. So again, as you take that black top and close it, these shelves will close into the box, but they'll always remain parallel. They'll always stay parallel to the ground. They'll stay in the same level. And the reason is because, if you look, AD is congruent to BC, so the top and the bottom are congruent, and AD and BC, that's the left and the right, and then AB and CD are congruent, that's the top and the bottom. So therefore, if both pairs of opposite sides are a quadrilateral, and they're congruent, then that quadrilateral must be a parallelogram. And by definition, if the opposite sides of the parallelogram are parallel, and since these two things, AB and DC, are attached to the shelves, and AB is always parallel to CD, then the shelves must always be parallel together, or to each other. Alrighty, so now you can start your homework here, which is an IXL H89, proving a quadrilateral is a parallelogram.